Hello everyone, my name is Yunsong Zhao, and it's my final project to build face recognition system of the Facebook project. Firstly, let's talk about the core problem statement of the face recognition system data. The goal of this project is to build a face recognition system to recognize its face for my classmate. But in the real world, the face recognition system always meets with some challenges that they only access one or very small number of symbols to represent a person's face. And in that case, traditional deep learning algorithm cannot make sense. Therefore, the face recognition systems always use one-shot learning methods. And the one-shot learning methods prefer that such learning algorithm can generate from a few or single symbols to new situation. And for the face recognition system, most of the one-shot learning method is based on the differences between the face images. And in my project, I will use the triplet network, one of the one-shot learning methods. And there is the introduction of triplet network, as you can see. It consists of the same subnetwork with shared width and takes 3 input data points at a time: anchor, positive, and negative. And the goal of the network is to learn a feature space in which the distance between the anchor and the positive is minimized, and the distance between the anchor and negative is maximized. And the loss function is here. So the triplet network will minimize this loss function. Next, I will introduce math algorithm structure. And as you can see, it's my structure of my algorithm. Firstly, I will prophesize the raw data size to train the triplet network, and the data size is the open source. For training the triplet network, the data size need to be divided into 3 parts: anchor, positive, and negative. Besides, as deep learning network, the data size need to be divided into training data size and test data size. Meanwhile, I will set the random seeds. That's because setting a random seeds ensures that every time the code is run, the data is splatted in the same way. It's important for training the deep learning network. And then, with the triplet loss at the loss function, the triplet network will be trained to get the image encoder in that feature exciter to get the image differences. And since the triplet network cannot directly classify the face images, rather it can find out the distance between the input images. Therefore, I will just use the triplet network to get the image encoder in that feature exciter. Specifically, when the input images represent the same person's face, the network will learn the parameter including width and basis to minimize the distance between the feature of such 2 images. In contrast, when the input images represent the different person's face, the network will maximize the distance between the feature of the 2 images. And then, with getting the image encoder in that feature exciter from triplet network, the differences between images can be calculated. And then I will set the fixed-out method to check the face images, whether from the same person or the different person. In that, when the differences will be smaller than fixed-out set by me, the label will be the same. Well, if the difference is over the fixed-out, the label will be the different. So the importance of my system is how to train the idle triplet network, as you can see. Then let's talk about it. As you can see, I use the exception model as the base model, and the expansion is the pre-trained model on the ImageNet, which is always used to image classification tasks. And the exception can be called by TensorFlow in Python. As my code said, the pre-trained model on the ImageNet expansion parameter is here, and the weight is ImageNet. The include top is false, means that the output layer cannot be included in the load model. And the plotting is AVG. Refers that I use the average plotting method. And after pre-trained model exception, the feature exciter also consists of 2 fully connect layers and 1 L2 normalization layers to normalize the data merely. Specifically, after the pre-trained model exception, the next layer I set is filtering layer, which takes the output of the exception and filters it into a 1D array. It's important for the next step in this network. And then the full connect layer is zeroed, whose activation function is ReLU. And the designs with 512 numerals can be added. Then it adds a bench normalization layer, which helps to establish learning by normalization the input layer by resetting and rescaling. And the other full connect layer is zeroed by bench normalization layer. This dense layer is with 256 numerals and use the same activation function as before. Finally, connect the layer to normalize the vectors, and it's my triplet network model. So after training it, I will give my model result. But since my laptop cannot provide stronger compute power, I just set the approach is 10 for training the triplet network. I show 2 indicators, training loads and testing currency, to represent the performance of trained triplet network, as you know. And based on both result images, it can be found that the overall performance of my model is good, I think. Specifically, the training loads is continuous decreasing, ranging from 0.5 to less than 0.1. That means with the approach increasing, the performance of model in the training data size will be better. And then the images is show the testing occurrence. It can represent the performance of model in testing data set, which is important for a specific deep learning network. That's because the testing occurrence shows the model generalization ability. So it can be found that the testing occurrence is always around 0.9, which is enough here, I think. That means such trained triplet network model has stronger robustness and generalization ability. And after training the network, I will get the feature exciter from it. As my code shown, the feature exciter is the layers in which the trained triplet network removes the input and output layers. Then I will apply the csort method. That means I will compare the differences between images with csort set by me. Okay, is the result. I used the testing triplet data size to evaluate the performance of the system in that my model. I input the three types of data, anchor, positive, and negative, into the network, which consists of feature exciter, collecting the differences and sets of methods. Finally, I use the confusion matrix to visualize the performance of the face recognition system. The middle one is the bias, as you can see. The C-salt is set 1.4, and the currency is the 0.814. And I set different C-salt to compare. The D-salt is 1, 1.4, 1.8 respectively. And the currency of the model is 0.79, 0.814, and 0.796. That means it will affect the output results of the model, whether the C-salt value is too large or too small. Specifically, the C-salts are too small that the true similar will be smaller, the false similar will be larger. In contrast, the C-salts are too large, the true different will be smaller, and the false different will be larger, as you can see. Therefore, choose the proper C-salt is important for my project, I think. And I know I will build the end-to-end face recognition system for check the classmate whether it's in the classroom. And in my project, I built the model, in that the algorithm model, and with the vector database and camera, I can construct the end-to-end system, and it will be achieved in my future, I think. Specifically, this is my idea. Firstly, the classmate will be captured with the camera, and each of the images of the classmate's face will be input in my model, which is redriving the vector database, including all of the classmate's face images. And then, when they find out the similar images in the database, such images will be labeled as the same. Finally, the output is the images that are not labeled as the same. And in the output, I can check who is not in the classroom. And as you can see, the model results are not accuracy enough to apply on the commercial situation. I think the main reason is that these auto methods cannot perform well, regardless of specific image cases. Besides, since there exact noise and category overlap in the real world and the real data, traditional triplet loss maybe cannot perform well. So for the loss function, I check the material to find the soft triplet loss. And the soft triplet loss may be performed better, which introduce softened bond that allows for some degree of overlap. That means even if the distance of the negative simple pairs are slightly smaller than the distance of positive simple pairs, it doesn't quickly lead to a maximum loss, as you know, and the loss function is here. And then I will find a better methods than directly C-salt methods. I find a method that can dynamically updating the C-salt. Specifically, the C-salt is dynamically adjusted based on the data encoded in the real-world application. As you can see, based the soft triplet loss and dynamically updating C-salt, and with the vector database, including all of the classmates and the camera, I can construct the end-to-end face recognition system. This is my future work, and that's all. This is my project.